So in this video I want to explain how to solve this differential equation, because that was an exercise in the lecture notes, and I was asked whether I can clarify the situation or to explain how to solve it. And of course I can. So let's do it. So first we have to see, okay, it is an inhomogeneous problem. So we see, okay, there's a term that just contains only x and no y. So it's an inhomogeneous differential equation. So we transform this into the homogeneous part. So we have y double prime plus y prime minus 6y equals 0. So now we have the homogeneous differential equation, and we know very well how to solve this, because we can transform this into its characteristic equation, which is k squared plus k minus 6 equals 0. And well, this is a simple equation, quadratic equation, and we all know how to solve this. And I abbreviate the calculations here by just transforming this term into the following equation. It's just k minus 2 times k plus 3 in brackets equals 0. So we see this is k1 is 2 and k2 so is just minus 3. So this equation has two zeros, and they are both real numbers, and they are different. So it's clear that the general solution of the homogeneous differential equation is just c1 times e to the power of 2x plus c2 times e to the power of minus 3x. And what is left to do is to find a particular solution for the inhomogeneous differential equation, and then we are done. So what I taught you is, okay, now we just go back to our inhomogeneous differential equation, and since we know that the source function, which is over here, is in variation of the exponential function, we know how to approach this kind of inhomogeneous differential equation. So we start with the following. So we believe, so to say, that yp is just a function of this kind, a times e to the power of minus 3x. This minus 3 stems from this minus 3 over there, and this has to be kept here. So we're not allowed to change this or to replace it by something else. So it must be minus 3 because it's minus 3 over there. Yeah. So now this is the standard approach if to find a one particular solution, and well, then we have to calculate just the first derivative, and it's just minus 3a e to the power of minus 3x, and the second derivative is just y double prime is just 9 times a times e to the power of minus 3x. Yeah, so that's the standard how to approach such kind of inhomogeneous differential equation. And what do we have to find out is now what is a good solution, or good choice of A in order to solve the inhomogeneous differential equation. And to find this, we have to just plug this into our differential equation again. So our differential equation is over here. It's this one. We just plug it into this and see what is a good value for a. So we have y prime plus y double prime plus y prime minus 6y has to be minus 3 times e to the power of minus 3x. So now we know what y double prime is. In this case, it's just 9 times a times e to the power of minus 3x plus y prime. This is minus 3a times e to the power of minus 3x, and minus 6 times y. So we have minus 6 times a times e to the power of minus 3x. And this has to be minus 3 e to the power of minus 3x. Okay. We can just cancel this e to the power of minus 3x, because e to the power of minus 3x is always not 0, and it appears as factor in all terms, so this just boils down to 9a minus 3a minus 6a, and this must be minus 3. And this can be simplified to 0 must be minus 3, and this is a contradiction. So this standard approach fails here. Maybe you remember the angry cat. And yeah, in this case, when the standard approach does just fail because of you end up with a contradiction. So there is no a of that kind. We have to improve our first attempt here. So the way to do this is by the variation of the constant. So we have to apply variation of the constant, and what does it mean? It just means that yp is not a times e to the power of minus 3x anymore. It is a of x. So we just assume it's a function now. And on our first attempt was just saying, okay, it's just a constant here. And now we have to improve our approach, because with this assumption it simply fails, and to do so we just assume a is now a function that depends on x. So we have a more sophisticated approach here. That's nice, but the drawback of this approach is that the first derivative and the second derivative now become more complicated, because now we have to apply the product rule when we compute the first derivative. So if we compute the y prime, well, it's just the product rule that says it's y a prime times e to the power of minus 3x minus 3 times a of x times e to the power of minus 3x. And this can be simplified to a prime of x minus 3a of x times e to the power of minus 3x. Yeah, so we have now found the first derivative, and we need the second derivative too. So let's compute the derivative of the derivative. And again, we have to apply the product rule. So what we end up is, first we compute the derivative of this one. So it's a double prime of x minus 3a prime of x times e to the power of minus 3x plus, and now we have a prime of x minus 3a of x times minus 3 times e to the power of minus 3x. So now we have y double prime, and we can simplify this to a double prime, and we have minus 3a prime, and together with this minus 3 over here we have 6 this one and this one, we have minus 3a prime over here. So in sum we have minus 6a prime of x, and we have plus 9a of x, because we have minus 3 here, minus 3 there, so that leads to plus 9 over here times e to the power of minus 3x. So that's the second derivative of y prime when we apply the variation of constants. Yeah, and now we have to plug this into our differential equation again. So we have to go to this equation and just try to find out what happens to this equation when we apply our next attempt to find a particular solution. So we have y double prime plus y prime minus 6y y, and this is, well, we just have to write down, it's just notice every function has this term here, this common term. So y double prime has this common term, this has this common term, and that has this common term. So if we just sum it up in this way, what we end up is we have this e to the power of minus 3x always as a factor, And now I have to consider this y double prime. It is just a double prime of x minus 6a prime of x plus 9a of x. Okay, then we have this y prime. Y prime is this vector times a prime minus 3a of x, and a prime of x, of course. So let's write it correctly. And finally, we have minus 6 times y, yeah, and this is just minus 6a of x. So we have minus 6a of x, and that's the differential equation, the left-hand side of the of this differential equation. And just let us put this together. And then we have a double prime of x, and we have minus 6a prime plus a prime. So we have, in sum, we have minus 5a prime of x, and we have 9a of x minus 3a of x minus 6a of x. So there's no a of x. So that's the left-hand side, yeah, of the differential equation, and this shall be the right-hand side, which is just minus 3 times e to the power of minus 3x. Yeah, and as a consequence, we know, we observe, okay, everything is nice, or everything is clear, and this equation holds in cases where a of x, a double prime of x minus 5 times a prime of x is equal to 0. Oh, sorry, minus 3, of course. Okay, minus 3. Okay, and this can be satisfied with the following choice. We just choose a double prime of x to be 0. A prime of x is constantly 3 over 5. And then we are done. Yeah, I hope that you see, if I choose it that way, yeah, then this equation just holds. Yeah, because this is just 0. We just choose a such that the a double prime is 0, and then this term is 0, and if a prime happens to be 3 over 5, then the 5 cancels, and we have just minus 3 equals minus 3. So that's nice. And if this choice would do the trick. Yeah, and how to solve that? Well, just choose a prime to be 3 over 5 times x, and then you're done. Because if a of x is this, you know, okay, this a prime is 3 over 5, and a double prime is just 0. Yeah, so okay, now we have found a solution for the inhomogeneous differential equation. So the general solution now is so yp is just 3 over 5x, so this is the particular solution that we found, plus the general solution of the homogeneous differential equation. This is c1 times e to the power of minus 3x. What was it, 3x? Was it this way? Okay. E to the power of 2x plus c2 times e to the power of minus 3x. Yeah, and if you just don't trust me, yeah, then we can just oh, sorry, I forgot this. This is the trick. Now, okay, yet another correction. Here I missed the e term, so I can just move it to the right. This stuff here. And fix that problem with just this trick, e to the power of minus 3x, and then we are done. So this is the particular solution that we just derived, from our calculations. A of x must be 3 over 5 times x. So this is the solution, the particular solution that helps us to find the general solution of the differential equation, which is inhomogeneous. And if you don't trust me, you can just try to find out what if yp is just 3 over 5x times e to the power of minus 3x. And well, then you can just compute what is the first derivative. It is just 3 over 5 e to the power of minus 3x plus 3 over 5 x times e to the power of minus 3x times minus 3. So this can be simplified to 3 over 5 minus 9 times 9 over 5x, and this in brackets times e to the power of minus 3x. Okay, and y double prime, well, it is just the derivative of this one, so we have minus 9 over 5x, not the x, sorry, times e to the power of minus 3x, plus, now the bracket, 3 over 5 minus 9 over 5x, times e to the power of minus 3x times minus 3 because of the product rule. And this can be well, rewritten as, okay, we have minus 9 over 5, and we have minus 9 over 5 plus 27 over 5x times e to the power of minus 3x. So that's the second derivative of our particular solution. And let's see what happens if we plug this into our differential equation again. So the differential equation was y double prime plus y prime minus 6y. And this shall be minus 3 times e to the power of minus 3x. Okay, let's assume, let's just take this this sum here and plug in our values for yp. So what we have is e to the power of minus 3x. So because we have this common term here in all cases, for all functions. And if we have just y double prime, we have minus 18 over 5 plus 27 over 5x. So for y double prime, and next is we add y prime, so this is plus 3 over 5 minus 9 over 5x, and finally minus 6 times y, so we have minus 18 over 5x. Okay, and this just is e to the power of minus 3x, and now we have just to sum up. And what we see is the following. What we have terms with x, so 27 over 5x minus 9 over 5x minus 18 over 5x. Oops, so this just cancels. And what is left is minus 18 over 5 plus 3 over 5. So what we have is minus 15 over 5 as factor, which is just minus 3 e to the power of minus 3x. And that simply says, okay, the differential equation is solved, with this particular choice of a of x. Okay, I hope that helps.